Hi, and welcome to Module 15. In this module, we will continue to explore the size of the intergalactic space of the universe and learn about quasars and blazars. A quasar is a very energetic and distant galaxy with an active galactic nucleus. The term quasar stands for quasi-stellar radio source object. They were first identified as being high redshift sources of electromagnetic energy that appeared to be similar to stars rather than a galaxy.
Again, quasars stand for quasi-stellar radio source object. They have huge red shifts and emit all kinds of radiation.
Quasars are deep space objects that emit a huge amount of energy, especially radio, from a small volume. They are the most luminous objects in the universe. In 1963, 3C273 was the first quasar ever to be identified. This combined X-ray and infrared view shows the radio source 3C273 and the luminous jet it has created. The jet is also visible in the radio and visible parts of the spectrum. So let's learn a little bit about quasar 3C273. Its mass has been measured to be approximately 886 million solar masses. Its large-scale visible jet is about 200,000 light-years long. Plus, the redshift of this quasar is so great that it is over 2.4 billion light-years from Earth and has the distinction of being the first intergalactic X-ray source discovered in 1970.
Take note of that 886 million solar masses. That means that quasar 3C273 has 800 million times the mass of our Sun.
The energy output of a typical quasar per second is equal to the energy emitted by the Sun in 200 years.
And this is absolutely crazy. Our Sun burns 600 million tons of hydrogen per second in a thermonuclear fusion reaction, but a quasar can emit the same amount of Sun's energy in 1 second that it takes the Sun 200 years to produce. That is crazy talk.
More than 100,000 quasars have been discovered. All quasars have redshifts of at least 6% the speed of light, with upper limit speeds corresponding to 90% of the speed of light. From the Hubble law, it follows that the distances to these high redshift quasars are typically in the range of 10 billion to more than 13 billion light-years from Earth.
And our current end detection limit is about 13.7 billion light-years.
In summary, there is now a consensus that a quasar is a compact region in the center of a massive galaxy surrounding the central supermassive black hole. Its size is 10 to 10,000 times the Schwarzschild's radius of the black hole. The quasar is powered by an accretion disk around the black hole. There are other active galaxies, and quasars are just one type of very powerful energy source in space. The others include Seyfert galaxies, radio galaxies, double radio sources, X-ray galaxies, and blazars.
Just introducing you to some of the other galaxies. You can do research on your own. It's way beyond our course.
In 1944, the first radio emission galaxy was discovered in Cygnus A. Its spectrum was able to be photographed, from which it was determined its redshift was 7,000 miles per second. According to Hubble's law, this speed indicates that Cygnus A lies 635 million light-years from Earth, and its recessional velocity is 5% of the speed of light.
By radio emission, we mean, instead of light emission, we mean noise emission, static. Radio emission.
Blazars are another type of distant active galaxy. They are variable intensity objects that are brighter than quasars and change in intensity over a period of less than 1 day.
Again, another bizarre deep space object. Just an information slide.
A pulsar is a pulsating source associated with a rapidly rotating neutron star with an off-axis magnetic field.
So in addition to radio sources and light sources, we have stars and supernovas like the Crab Nebula that pulse on and off and emit X-rays as they pulse. Crazy.
A gamma-ray burster is a short burst of gamma rays. The sources of the bursts are outside our galaxy. They emit more energy than a supernova and from an even smaller volume of space. A short-lived gamma-ray burster is less than or equal to 2 seconds. A long-lived gamma-ray burster takes from 2 to 1,000 seconds. The property that indicates longer-living gamma-ray bursters are located at cosmologically large distances outside of our galaxy. This property is the presence of absorption lines from intergalactic gas clouds in the spectrum of remnant visible light following the gamma-ray burst. This is an image of the most cosmologically distant explosion yet detected. It is found at a distance of 12.8 billion light-years and happened in the spring of 2009. Cosmic microwave background radiation, or CMBR, is an isotropic radiation field surrounding the entire universe. It was discovered in 1964 at a distance of 13.7 billion light-years and is extremely cold, with a temperature of 3 degrees Kelvin. This discovery, by radio astronomers Penzias and Wilson, earned them the 1978 Nobel Prize in Physics.
What we discovered was that at a distance of 13.7 billion light years, no matter where we looked in the universe, we no longer got back electromagnetic light rays, but instead just got back radio noise, static. And this is considered the cosmic microwave background radiation, left over from the Big Bang, which never really happened.
With the traditional optical telescope, the space between stars and the galaxies, the background is pitch black. But with a radio telescope, there is a faint background glow, almost exactly the same in all directions. That is not associated with any star, galaxy, or other object. This glow is strongest in the microwave radiation region of the radio spectrum, hence the name cosmic microwave background radiation.
The discovery of the cosmic microwave background radiation was the linchpin in the formulation of the Big Bang theory of the creation of the universe.
Okay, here we go. The Big Bang theory was under development long before the 1964 discovery of the CMBR. In 1922, Friedman introduced the idea of an expanding universe that contained moving matter, an attempt to investigate Einstein's general relativity prediction of a non-static, universe. In 1927, Lemaitre would independently publish the same conclusion. He argued that the physical universe was initially a single particle, the, quote, primeval atom, end quote, as he called it, which disintegrated in an explosion, giving rise to space and time and the expansion of the universe that continues to this day, according to Hubble's law of expansion. Okay so far? Whew. Next, Lemaitre's idea of a unique primordial quantum would be given a theoretical physical basis in 1946 when George Gamow published his assumption that the primordial quantum universe of Friedman and Lemaitre was hot, i.e., that it would have been dominated by radiation rather than by matter. Moreover, Gamow realized that his hot, expanding universe should cool over time. In the early 1960s, Robert Dicke and Jim Peebles started to think about Gamow's hot primordial quantum. And they rederived the prediction of a cosmic microwave background radiation by Friedman and Lemaitre. Immediately, they set about building a radio wave detecting instrument, then known as a Dicke radiometer, to search for the radiation. But they were scooped by the accidental detection made by Penzias and Wilson of the CMBR, also using a Dicke radiometer, who were also working at Bell Labs, just a few miles from Dicke's group in Princeton. Science is amazing. Lastly, Lemaitre's hypothesis of the primeval atom became known as the Big Bang Theory in 1949, when astronomer Fred Hoyle coined the term during a BBC radio broadcast.
The Big Bang Theory is a theory, but not complete or perfect. Theories are hypotheses that have survived rigorous testing, but may be revised in the future as more knowledge comes to light. In the closing Module 16 discussion on cosmology, Professor Quasar notes how the concept of an ever-expanding universe, termed eternal inflation, is in conflict with the Hubble constant itself that describes the expansion of the universe. To give you a hint of the problem, for eggheads like Quasar, the space-time equations don't work with an eternal inflation model.
So in this module, we learned about deep space objects, blazars, quasars, gamma ray bursters, the mysterious cosmic microwave background radiation, which led rise to the Big Bang Theory of creation, universe creation, which didn't happen.